Our next speaker for the day is Akshay Gaikwad, who will be speaking on dependency injection in Go. He is a software engineer currently working at InfraCloud Technologies. So while he's setting up, please welcome Akshay.
So hello everyone. I hope I'm audible at the back. Thank you. So my name is Akshay Gaikwad. I'm from InfraCloud. I'll be talking about the dependency injection in Go. So let's get started. A bit about myself. I work at InfraCloud as a software engineer. I have been working on Go for 1 year, and in InfraCloud, I get a chance to work on building a software from the scratch. You might have seen the morning talk by Vishal, which was around how we open source a couple of projects. So that's how I got to get a chance to understand the design pattern and how can I use that for my building application. Apart from that, I'm an open source enthusiast. I work on a couple of free and open source softwares. And yes, I'm a Golang user and developer. You can check my GitHub ID, which is Akshay196 for the codes. And I write sometimes at akshayg.in. Yeah, that you can check out later. So before we get started, why are you talking about a design pattern? So how many of you know the design pattern? Those who write codes. Can you raise a hand, maybe? Yeah, quite a few, right? So those who know the design pattern, it was an old technique for writing application. It's been in market for a long time, and you might have heard about if you worked on the Java, you might have heard about the design pattern and gang of 4 books like that to understand that. In Go, the way we write code is pretty simple, or it's straightforward. So why do we need design pattern, or particularly the dependency injection in writing code? So while developing the softwares, I have been writing code, and then I realized I have been using some pattern which are already exist, and I have been using that for my code. And I was not aware or not conscious that there are a lot of benefit that it provides when your code when you're actually maintaining the code or scaling your code. Okay, so the first thing we will talk about the dependencies. I know a couple of you have heard about the dependencies from the morning, and the challenges when it comes to managing the dependencies and having the access to the dependencies in your code. Then we will exactly understand what dependency injection is, what are the benefits of it, and at last I will give a quick demo of how we can use that in your code. So what are dependencies? So you might have already know that so our application may depend on some kind of library, framework, or tool that is required to accomplish whatever our goal of our application is. So for example, if you are working on some authorization application, or some application working on looking for some authorization, you might have used Casbin or some other tools for doing the authorization. Similar to that, there are a lot of dependencies that your application might have. So to set a context for my demo, let me introduce, take an example of few dependencies. For example, logger. So I hope when you work on any application, you need logger to log the warning, error, or any kind of informational messages, so that you can debug your application later. The second one is config. Yeah, to customize your application, you need some kind of config. The way you can customize it. For example, if you are working with database, you can fetch the database DSN value from the config. Just an example. And at last, yeah, if you are maintaining the state of our application or storing some data, you need a database. Yeah. So if you take this example, three examples of dependencies. So like if you see the below of the diagram, so it basically logger is depending on the config. For example, pulling the some prefix or the timestamp format, and database is dependent on the logger for logging the requests that are taking time. And the database may depend on the config again to fetch the maybe DSN value or some other parameters. And those are like interlinked dependencies. So if you check the first three items or the blocks, those are like, for example, if you have written like a health check module, that may depend on config for looking for some environment variable or something, or the environment that you are running. For example, the user model. If you are working on some users, handling the users, then you need a user model that will depend on maybe logger and the database for fetching the data, logger for logging the request, then service, any kind of service that may depend on the database. So if you grasp this, so there are a couple of linking between all those modules or dependencies that we've used. And it becomes complex when the dependencies grows. So just to give you an gist of how much dependency that we can have. For example, our application may have a logger and database that we already saw. Our application may have the time provider for timing. Then your application may have a session manager for managing sessions. Then some kind of external API, maybe if you are talking to some external services. And it can be like cache for handling the caches. Yeah. So if you can relate to this, like your application may have multiple dependencies or many dependencies that you need to work with. And that creates a problem because you need to manage all this, and whenever you require particular dependency, you need that for that code or for that module. So let's talk about the problems when we see the dependencies. So first problem is how can we construct and uses the dependencies that are like independent. For example, if I'm constructing a dependency and I'm also using that one, how can we break that apart so that our code can be more modular? And we can definitely follow the separation of concern principle here. The second problem that I have seen, like to replace dependency, we don't want to be rewire everything. Yeah. So if I'm replacing dependency A with dependency B, then I don't want all the application or all the structure of application get changed. That will be nightmare for me. And third and most important requirement, I would say, is how can we test our application, right? So testing is important. So, and when it comes to testing, how can you mock the dependencies, right? So let's talk about some of the approaches or traditional way how we can do that. So first example is like instantiating dependencies as we want it. Just to give an example, if you are working on a web application, you may have a handler, and that handler required a logger. Okay. So what I have done inside that handler, I created a logger, and then I can use that logger in the same handler. Okay. So that's a piece of code that I've shown on the slide. So, so the problem with this. The dependency or constructing dependency is hard-coded into our code. That will lead to difficult in sharing your code with others. And you're not able to test. You're not able to, not composable. Your application is not very composable. And Let's talk about the second way how we can do that. We all know like we can set up some global variable and use that for whenever we require any variable or any dependency. For example, the same example, I have initialized a logger, which is now global variable, and whenever I require, I use that inside any piece of application or component. The problem with that, the global state is unpredictable. So for example, if your application has multiple components and the same global variable is being used by multiple components, then if there is a side effect from the one component that affect the global variable, that means you cannot predict the initial state of that variable in the second component. And second one is like it hurt the readability. For example, if your code has an external dependency that isn't explicitly introduced in your code, the job who is maintaining your code has to, the person who is looking for your code has to look for how that dependency is introduced in your code and how it is managed. So what is dependency injection then? How can you use that to eliminate all the problems that I have shown? Yeah. So in simple terms, dependency injection, we can define it as like object or function receive other object or function that it depends on. It's very simple. Or in very lazy way, we can say that like it's passing parameters to a method. So typically, receiving object is called as a client, and the passed in or injected object is called as a service. So if you try to write the earlier code using the dependency injection, so we can basically pass in any the parameter or parameter to our function. For example, this logger. So logger can be passed into as a parameter to our handler, and that can be used inside that. So the benefit of this is, I will talk about the benefit later also, but to give you an idea, the creation of handler is decoupled from the creation of that dependency. One another way you can, definitely you can use the interface that can be act as a parameter to your handler or any function that requires that dependency. So basically, we can pass anything we want into handler as long as it satisfies that interface. So let's look at the benefit. Why do we need that? Like, what's the advantage of using dependency injection? The first thing, loose coupling. So dependency injection decrease the coupling between the creating the dependencies and using the dependencies. Second one is like, by removing the client knowledge of how dependencies are implemented, program become more reusable, more testable, more maintainable, which results in increasing the flexibility. Client may act on anything that supports the interface the client expects. It reduces the boilerplate code. So all the dependencies are constructed at the singular component, and then it will be passed on to whatever component that they require. And it also allows us to do the concurrent development of our software, because we don't need to understand everything, because the component that requires some kind of dependency has to that only component needs to know the knowledge of how that dependency can be injected in the component. So let's just take an example. I will give a quick demo of how it works. So in here, I have written a small application. In main.go, I have created a struct, application struct, which has a couple of dependencies. For example, the config, the logger, the user, which has the user model. Then I have also a config decoder that can be used to decode the config. And I just kept it in the one struct that will be like acting as a container for your application. And in main.go, I have constructed all those like dependencies. And then here, if you can see it, like I have created an object of the application struct and passed in all the dependencies, and then you can basically call the function, and that all the dependencies can pass to the required component. So if I run this code, you will see that like it's working fine. So for example, I'm getting the environment variable from the config and starting the server. That's it. Okay. So now, so somehow we change our config to YAML from YAML to JSON. So how can we replace that the config decoder here? So if you check the config decoder again, it's just an interface, and we just require the decode function which takes in the interface again and return an error. So it's a pretty common decoder that every bit like the YAML and the JSON or any other encoder decoder library have used. Now, if I want to use the JSON decoder, I created this JSON decoder, and yeah, first I check on JSON file. And I just wanted to now replace the config decoder with from YAML to JSON. No, that's it. Like I replace one dependency with another. So how if I run the code again? Yeah, it still works. Yeah. The format of that JSON and YAML is still same. So we're just replacing one with another. So yeah, that's how we can replace the dependency. But what about the testing? The testing is the most important part here, right? So how can we test that? Just to understand the concept, I have written a simple test here. You can see here for testing the particular handler. So this is not like a real world example, but just to give you how we can do that in using the dependency injection. So I've created the application here, but at this time, instead of using the real dependency, I mocked it with some kind of mock dependencies. So this is kind of like the mock dependencies that I'm using. So for the get handler, so for the get user model, I'm returning the ID and name with the mocked user. So if I want to test this now, yeah. So in my test, instead of using the real dependency, I'm using the mock dependency. Just like how, so basically it's printing the username here, nothing else. So that will give you an idea of how we can basically test in particular model, or how can you replace the dependencies. So going back, if you look at the problem that we seen in the initial slide, for example, constructing uses of dependencies, how can we differentiate that? Yeah, so as you can see, the main has all the code for constructing, and the handlers has all the code for usage. The second one was how can you replace? Yeah, as you can see, we can replace one logger with another, or replace one config decoder with another. And the last one was, yeah, the mocking. Yeah, as we saw, that we can basically mock the dependency. So simple takeaways from the slide. So yeah, dependency injection is simple, but yet powerful, the design pattern that you can use. Dependency injection help you in write code that is easier to test and maintain and understand. So that's all I have. Thank you very much.